What up, folks? What's going on? Well, I'm in the lab today and I'm playing with some crystal cells using quartz crystal and shungite material mixed together with glue, and I put them on plates. I got a copper plate that was previously nano-coated and an aluminum plate which was nano-coated, both by different means. And we'll go over here and see the materials I'm talking about. So this is the quartz crystal. It used to be this guy here. Broke it down into smaller pieces with a hammer, then further crushed it with a makeshift ball mill. I just used this piece of aluminum bar we had cut for another project. Mix that with this here. This is shungite powder. You can get it from Russian mines. Mix that together with some pretty standard white glue. And then we put it onto these plates. So these are all aluminum foil. And this one here is a piece of titanium as one side of the electrode. Well, I'm going to see what that is. I haven't tried that one yet. But the one here with the copper, found that I get it usually between 500 and 600 millivolts. So that's kind of nice between the two, and I figured, well, I want to do something practical with it. Let's do some work. So I'll light up an LED with it. But how do you light up an LED with only 600 millivolts? You use a jewel thief ringer. So I got the circuit. See right here. It's just a NPN transistor with a 1 kilo ohm resistor and a bifilar wound toroid, which I've assembled over here, and just testing it out here. Got my power supply running on 6. It's not really going on. Sometimes it goes on and off. It's kind of finicky, so we can get it going. Oh, there we go. That's at 20 milliamps, 0.8. That's glowing nice and bright. Let's see if I can block the light there. You can see it glow. There. Yeah, that'll do. So I'll try to bring that down about the lowest I can. And it's about there. So you can see 0.6 lights it up. So this little guy, let's see what the voltage coming off this guy is. Let's turn our jewel thief off. Our handy dandy meter. Put it to volts. And come over on this side. Copper is our negative. Yep. And then we got our positive here. So maybe I can put it in shot so you can see it when I connect it. That's kind of awkward. There we go. So we got it. So looks like right now it's not giving me as much as I'd want. It's kind of sensitive. I think it might be that guy there. My connection onto the aluminum foil is a little finicky, it seems. But no matter. Try to. Ugh. See if we can get it going. Right, so what it turns out is that it lost pressure from just being open like that. I gotta somehow keep it locked in, because the more pressure you put on it between the plates, you get more voltage. I'm guessing that has some relation to the Casimir effect. Anyway, so we should be able to see this thing light up that jewel thief. So let's try to plug that. Well, try as I might, it didn't seem to work. Couldn't get it running off of just the one cell. It seems the cell's not really putting too much more than 550 millivolts. So we'll try a different cell. I think that's something. Suddenly, it's up at 635 millivolts. Anyways, what I've got is another one of these plates that I put together, and this guy turns out to be about the same amount. This one is instead of a copper plate, I put a piece of titanium sheet, and that's aluminum foil with the quartz stuff in the middle. And let's get a reading. So even though the second plate combined with the other one in series gave a voltage of about 1.4 on this meter, this guy doesn't show the same kind of readings, and couldn't get the light to work, so we'll try something later.